Hello students, in today's mathematics class, we are going to discuss limits from calculus. Already you learnt different chapters of calculus, functions, limits, derivatives, all these things in your regular program. And now, in this video classes, I am going to handle limits and derivatives by reviewing as well as reminding your previous knowledge along with certain interesting points and markable problems. Let us start today's topic, limits. In particularly, limit of a function at a point. Why we need limits? Basically, limits helps us to analyze the nature of the function in different points. Nature of the function is different at different points, and for suppose if you wish to analyze the nature of f of x at a point a, the concept of limit helps a lot. See, to analyze the nature of the function f of x at x is equals to a, we need to observe the functional values of f of x in the deleted neighborhood of a. We need to observe the functional values in the deleted neighborhood of a. So, now the question is, what is meant by this deleted neighborhood of a? Neighborhood in the sense surroundings of a. See, you need to consider a small interval in the surroundings of a. Mathematically, we represent a minus delta to a plus delta for very small delta. For very small delta, very small positive delta, this particular interval a minus delta to a plus delta is considered as the deleted neighborhood of a. That in the sense, you need to consider the values which are very nearer to a. You need to imagine this interval as small as you can, and from this interval you need to eliminate a. So, this is basically deleted neighborhood of a. You need to consider the values of x in the surroundings of a from both sides, from right side as well as from left side, and for those values of x, we need to observe the functional values of f of x. By observing those functional values, then it is easy to analyze the nature of f of x in the surroundings of a, and that is considered as the limit. For example, if you think about a function, for example, I am taking f of x is equals to x square is my function, and if I wish to analyze the nature of this f of x is equals to x square at a point x is equals to 2. At a point x is equals to 2. So, to find or to analyze the nature of f of x at x is equals to 2, we need to concentrate on the neighborhood of 2. Neighborhood of 2 is simply nothing but an interval which is very small as you imagine, right. For suppose on the number line I am just locating 2 here. So, you just concentrate on small region, small surroundings of 2. See, from both left and right sides of 2. So, these are the values of x. Now, for all these values of x, you need to calculate its functional values, f of x values. We know, see, at 2.1, what is the functional value? Since the function is x square, at 2.1 the functional value is 2.1 square, so approximately 4.41. And at 2.2 the functional value is approximately 4.84. And in the same way, at 1.9 the functional value is 1.9 square, which is 3.61, and at 1.8 it is 1.8 square, which is 3.24. Initially, I am concentrating on the surroundings of 2. Certain values from the right side of 2, certain values from the left side of 2, and those values are very nearer to 2, and I am not concentrating on 2 because my discussion is in the deleted neighborhood of 2. Now, at each and every point in that neighborhood, you need to calculate, observe the functional values like this. Now, if you observe here, see, as you change the values of x towards 2 from the right side, see, here I am changing the values of x 2.2, 2.1, 2.01 and 2 like that. If you change the values of x towards 2 from right side, whereas the functional values 4.84, 4.41 and at 2 it is 2 square which is 4 and the functional values are also moving towards 4. As I am changing x values towards 2 from the right side, the functional values are also changing towards 4. In the same way, if you observe the functional values from left side of 2, if you change the values of x from the left side, if you change the values of x from left side towards 2, again the functional values are rising and moving towards 4. Now, see, analyzation of the functional values of f of x in the right side of 2 leads to the concept of right hand limit, and analyzation of the functional values in the left side of 2 leads to the concept of left hand limit. Once if you concentrate in the right region, here the values of x are changing towards 2 from right side. So, x is moving towards 2 and the value of x is somewhat greater than 2. So, here see in the right side, when you think about right hand limit, okay, this is short form for the right hand limit RHL. When you think about that right hand limit RHL, x is moving towards 2 and x is greater than 2. Combining these two together, we usually write x tends to 2 plus. X tends to 2 plus, what it means? X is moving towards 2 from right side. X is moving towards 2 and x is greater than 2. As x is changing with these two specifications, the values of f of x are also changing towards 4. So, as x is moving towards 2 and greater than 2, we say that as x tends to 2 plus, then if you observe f of x is also tending to 4. F of x is also tending to 4. And in keen if you observe f of x, the values of f of x are moving towards 4 and that too decreasing towards 4, that in the sense the value of f of x is also a small value greater than 4, and that is why we say that f of x is also tending to 4 plus. Since f of x is tending to 4 plus, or sometimes we usually say it as 4, altogether we notate as limit x tends to 2 plus f of x is equals to 4. So, the right hand limit of the function f of x at 2 is 4. Right? In the same way, if you observe in the left side, as x is moving towards 2 from the left side, here x is moving towards 2 and the value of x is less than 2. In this situation, the functional values if you observe, they are again moving towards 4. So, here we notate like this, limit x tends to 2 minus f of x is equals to 4. So, discussion of right hand limit is as x tends to 2 plus, and discussion of left hand limit occurs as x tends to 2 minus. In both the ways, in both directions, in both sides, we need to observe the functional values. Here from both the directions the functional values are approaching to 4, but for right hand limit the values of f of x are bit greater than 4, and for left hand limit the values of f of x are less than 4. So, here left hand limit is 4 as well, right hand limit is also 4. Since these two, left hand limit and right hand limit, are equal, then in this case we confirm that the function has a limit at the point 2. Always it won't happen. For certain functions, left hand limit is not equals to right hand limit, and we will discuss one by one. Just we discussed the limit value of function x square at x is equals to 2. As we observe, the right hand limit is 4 and left hand limit is also 4, and in this case both left hand limit is equals to right hand limit. Okay. Now, I am going to analyze the nature of f of x, or I am going to find the limit of the same function x square at x is equals to minus 2. And now you just concentrate on the neighborhood of minus 2, certain values in the right side of minus 2 and certain values in the left side of minus 2. Okay, just have a look here. See, minus 1, minus 2, minus 3, this is the way we represent numbers on the number line. In the right side of minus 2, these are the values minus 1.8, minus 1.9. and the left side of minus 2, these are the values which are nearer to minus 2 in left side, right. Now, when you calculate the functional values, for minus 1.8, the functional value is minus 1.8 square, because our function is x square, f of x is equals to x square is our function. Minus 1.8 square is 3.24 and this is 3.61, and at minus 2 the value is 4. At minus 2.1 the value is 4.41, and at minus 2.2 the value is 4.84. Just to discuss, I am considering certain known values, okay. I am not moving, see, if you wish to analyze in keen, you need to consider the values which are in between minus 2 and minus 1.9 also. But just for our discussion, for the convenience of discussion, I am taking these as my x values. If you change the values of x in the right side of minus 2, that in the sense, as you are changing x values towards minus 2 and that x value is greater than minus 2, here again the functional values are increasing, right, 3.24, 3.61 increasing and moving towards 4. In this case, if you observe, see, this is the analyzation of the function in the right side of minus 2. So, this erases the concept of right hand limit, and we notate it like this: limit x tends to minus 2 plus. Minus 2 is the point where we are discussing the limit of f of x, and since we are discussing in the right side, so we need to mark it as minus 2 plus. So, in the right side of minus 2, we will notate that limit x tends to minus 2 plus x square value is what? And that value is again approaching to 4. So, the limit value is 4. So, limit x tends to minus 2 plus x square is 4. Limit x tends to 2 plus x square is also 4. Limit x tends to minus 2 plus x square is also 4. But in keen, if you observe, so in some situations we need to mention what is the exact value from where we are approaching 4. See, here as extending to 2 plus, the value of x square is approaching to 4 and it is somewhat greater than 4. So, clearly it is 4 plus, whereas in this case, as x is tending to minus 2 plus, the values of x square are approaching to 4, but those values are less than 4. So, we say it as 4 minus. But to answer the limit of the function, usually we won't consider this 4 plus or 4 minus, we treat it as 4, right. So, here the value is 4, here the value is 4. This is the right hand limit. Whereas in the same way, if you think about left hand limit, limit x tends to minus 2 minus. Here we are changing the values of x from left side. And here the values of f of x are moving towards 4 and they are bit greater than 4. X is moving towards 2, f of x is also moving towards 4 and these values are bit greater than 4. So, limit x tends to 2 minus x square value is 4 plus in particular, but usually we say it as 4. So, here again the left hand limit is equals to the right hand limit. Since left hand limit is equals to the right hand limit, we say that limit exists for the function at this point also. As we discussed the limit of the function, left hand limit and right hand limit of the function at a point, now I am going to discuss the definitions of that right limit and left limit. See, right hand limit for the function at x is equals to a. So, in the right neighborhood of a, the values which are right side of a, we are going to analyze f of x. Here we notate as limit x tends to a plus f of x is equals to L. This is the right limit. What it means? As x is tending to a plus, f of x values are tending to L. As x is approaching to a plus, f of x values are approaching to L. Then in this case, we say that the right limit value is L. See, what actually extending to a plus means? Extending to a plus means the values of x are tending to a, as well the values of x are greater than a. X values are greater than a and x values are very nearer to a. So, see, for those values of x which are very nearer to a and greater than a, if you observe the function, if the functional values are very nearer to L, then we say that the right limit is L. In the same way, left hand limit. See, left hand limit, at the point x is equals to a is notated in such a manner, here extending to a plus. Extending to a plus means what? The values of x are approaching to a and the values of x are less than a. If the values of x are very near to a and if they are less than a, at those values, if the functional values are approaching to m, then we say that the left hand limit is some m. So, for some functions, as we discussed for x square, these two are equal, L and m are equal, and for some functions they are not equal, and we are going to discuss everything for which functions they are equal and for which functions left hand limit and right hand limit are not equal in the next point, right. If that L is equals to m, if the left hand limit is equals to right hand limit, then we say limit exists for the function at x is equals to a, and that is only considered as limit x tends to a f of x. So, if you wish to find limit x tends to a f of x, you need to find out both left hand limit and right hand limit as per the function. If these two are equal, then that equal value is considered as limit of the function at x is equals to a. See, let us look at some examples related to left hand limit and right hand limit. See, first of all, the first problem is bit a, limit x tends to 2x square. See, limit x tends to x square, just as I discussed, for right hand limit x square is approaching to 4, for left hand also x square is approaching to 4. So, limit x tends to 2x square value is 4, because left hand limit and right hand limit both are equals to 4. Now, you just concentrate on limit x tends to 3 step x. So, to discuss limit x tends to 3 step x, what you say about right hand limit? Right hand limit is nothing but limit x tends to 3 plus step x. I think you all know about step x. Step x is the greatest integer function. Its value is n if it is in between the consecutive integers n and n plus 1. Once again for you, I am just revising. Step x value is always an integer and it is n if the value of x is in between the integers n and n plus 1. This is the definition of step x, right. And the problem is now finding the limit value of that step x at 3. As extending to 3 plus step x I am going to discuss. Now, here think about x, x is tending to 3 plus. X is tending to 3 plus means what? Here two different situations are, two different restrictions are involved. One thing is x is tending to 3, other thing is x is greater than 3. Since x is greater than 3, how much it is greater? X is very nearer to 3, but it is greater than 3. So, in that case x value is approximately 3 point something. So, step x value is 3. Since step x value is 3, directly limit x tends to 3 plus step x is equals to 3. So, this is right hand limit for the step x at x is equals to 3. Now, in the same way, if you analyze left hand limit for that function. So, when you think about left hand limit, now here I am going to find limit x tends to 3 minus step x. Again, you just look at this x, how the value of x is changing. Here x is tending to 3 minus. Again, here two restrictions are involved. One thing is x is nearer to 3 and the other one is x is less than 3. Here the values of x are smaller than 3 and almost approaching to 3, that means nearer to 3, right. So, less than 3, right, and that is why x is in between 2 and 3, right. So, step x is equals to 2. Since step x is equals to 2, limit x tends to 3 minus step x value is 2 here. So, the left hand limit is 2. So, here in this case if you observe, left hand limit is 2 whereas right hand limit value is 3, both are not equal. So, here right hand limit is not equals to left hand limit, and so we say that limit x tends to 3 step x not exist because they are not equal, right. If they are equal, then only we say limit exists for the function. Since they are not equal, limit not exists for the function, because in the right side of 3 the function step x is approaching to 3 and in the left side of 3 the function is approaching to 2. So, since these two are different, limit not exists for the function step x at 3. The function nature, the function's behavior is different for different points. At 3 when you analyze, they are not equal, so limit not exist. But when you think about some other point as extending to 3 plus, what you say about that step x? What you say about the limit of step x? So just look at the problem. Now I need to discuss right hand limit as extending to 3.4 plus, extending to 3.4. Okay, it's not an integral value. So I need to calculate its limit value. Extending to 3.4 plus means as extending to 3.4 plus, x value is nearer to 3.4 and x value is greater than 3.4. X value is greater than 3.4. How much it is greater? It is very nearer to 3.4 but greater than 3.4, and that's why it is clear that x is in between 3 and 4. Since again it is in between 3 and 4, step x is 3. Since the function is 3, as x is approaching to 3.4 plus, the limit value is again 3. So the right hand limit is again here 3. Okay, then think about left hand limit. I am going to observe the nature of that step x as x is tending to 3.4 minus. As x is tending to 3.4 minus, what it means? X is tending to 3.4 and x value is less than 3.4. Here the values of x are less than 3.4 and almost nearer to 3.4, so that x for sure is greater than 3. Again x is greater than 3, and so step x is again 3 as per the definition of step x. Since step x is 3, limit x tends to 3.4 minus step x value is again 3. So at 3.4, if you observe for the function step x, right hand limit is 3 as well left hand limit is 3. So here left hand limit is equals to right hand limit. Since these two are equal, we will conclude that as x is tending to 3.4, step x value is 3, here limit exists. For the function step x, as x is tending to 3, limit not exist. For the function step x, as x is tending to 3.4, limit exist. So in the same way, if you observe the nature of step x at different points, one thing is very clear that the limit value for step x exists for non-integral values, whereas the limit values for step x not exist for the integral values. Not only at 3, you just choose any integral value. Okay, limit of step x at 3 not exist, at 4 not exist, at 5 not exist, at -2, at -3, at all those points step x limit not exist. But at non-integral points like 3.4, the limit of step x exists. This is one thing we need to memorize. Likewise, not only for step x, for fractional part of x, for modulus of x, for square root of x, for different functions which you learnt in functions chapter, you need to observe the limit values at different points. All these things are already discussed in your regular class. Just as a part of reminding and revising those things, I am just giving you some examples, and you need to analyze all other special functions and their limits, right? And now I have one more example here. F of x is a specially defined function, and that f of x value is, just look here on the board, x square minus 7 if x less than or equals to 7, and that f of x value is x plus 5 if x is greater than 7. Now let us look at another example. F of x is a specially defined function here, that f of x is x square minus 7 if x is less than or equals to 7, and that f of x is x plus 5 if x is greater than 7. Okay, this is the definition of the function, and now our intention is to find the limit of the function as x tending to 7 as well as x is tending to 8. Okay, just I mentioned 2 points here, 7 and 8. In the same way, you have infinite chances to find the limits at different points. You can find limit of the function at 6, at 5, at 4, at 3.5, at 7.8, like that. But here, since at 7 the function definition is different, so I am concentrating on that 7. Okay, what to say about left hand limit? See, left hand limit is simply nothing but limit x tends to 7 minus f of x. This value we need to find. So first of all, concentrate on x values. X values are approaching to 7 from left side, because it is left hand limit, from left side. So x tending to 7 minus involves with 2 restrictions. One restriction is x is tending to 7. X is tending to 7 means X is nearer to 7, and the other restriction is X is less than 7. Since X is less than 7, as per the definition of the function, for X less than 7, f of X is X square minus 7. Okay. So, using this particular X less than 7, I will rewrite the limit X tends to 7 minus f of X as limit X tends to 7 X square minus 7. Have a look. X tends to 7 minus, it has two restrictions, X tending to 7 and X less than 7. X less than 7 is already used by considering this definition, but still I need to use this X tending to 7. X is tending to 7 in the sense X value is almost equals to 7, so this value is also almost equals to 7 square minus 7. And we know that 7 square is 49 and minus 7 is 42. So, here the left hand limit is 42. The left hand limit is 42, and now you just try to find right hand limit. Right hand limit, here finding right hand limit is simply nothing but limit X tends to 7 plus f of X. Again, observe the values of X, and for those values of X we need to observe functional values. Here X is tending to 7 plus. As X is tending to 7 plus, again two restrictions are involved, X tends to 7 and X greater than 7. First of all, utilize this second restriction, X greater than 7. Using that X greater than 7 is simply nothing but replacing the function with this particular thing. Here X plus 5 is the function if X greater than 7. So, use it. So, then this limit X tends to 7 plus f of X will become limit X tends to 7 X plus 5. As X tending to 7, this value is approximately equals to 7 plus 5, and that is equals to 12. And for this function f of X, the right hand limit is 12, whereas the left hand limit is 42. Since these two are different, so limit not exist for the function at X is equals to 7. But whereas if you think about limit X tends to 8 f of X, limit X tends to 8 f of X, see, we need to think about functional values in the left and right sides of 8. Okay. So, for suppose thinking about left hand limit means X tending to 8 minus, and thinking about right hand limit is nothing but X tends to 8 plus. As X tending to 8 minus, X is less than 8, as X tending to 8 plus, X is greater than 8. For, see here what is the value of X? Less than 8 means what we need to consider? You have any chance to take X as 3 or 4? No. X is less than 8 but not that much small. That is very nearer to 8 and smaller than 8. That in the sense for sure X less than 8 in turn represents X greater than 7 also. That in the sense in this case the function is X plus 5, because for all values of X which are greater than 7 the function is X plus 7. Here clearly X is greater than 8, again you need to take X plus 5 as the function definition. So, in right side and left side of 8 the definition of function is same. So, in turn if you find the limits, the left limit and right limit both are equals to 8 plus 5, 13 and 13. So, left and right limits are equal and limit exists for the function at X is equals to 8. So, finally this example will give us one clarity that limit of a function exists at a point if its definition is same in left and right sides of that particular point. If the definition or the behavior of the function is different in left and right sides, then left hand limit is different from right hand limit, and so limit not exist. Okay, let us look some more examples. Here for the first problem, this is the function and I am going to calculate the limit of the function as extending to 5 minus. That means this is about left hand limit. And the next bit, here this is the function, and here I am going to calculate the limit for this function as extending to 2 plus. So, this is about right hand limit. And for the last one, this is the function and we are going to calculate limit of this function as extending to 0. Here left and right are not mentioned. So, we need to analyze left limit as well right limit, and finally we need to conclude whether limit exists or not. See, let us look at the first one. See here X is approaching to 5 minus, left hand limit. So, as X is approaching to 5 minus, Here x approaching to 5 minus involves with two restrictions. X is approaching to 5 and x is less than 5. X is approaching to 5 means x values are very near to 5 and x is smaller than 5, x less than 5. And since x is less than 5, what to say about x minus 5 and which is less than 0, right? X minus 5 is a negative value. Since x minus 5 is a negative value, what to say about 1 by x minus y? As x is tending to 5, right? X less than 5 and x minus 5 is less than 0, and we say that 1 by x minus 5, see, just look here, x minus 5 is less than 0 and it is almost nearer to 0. As x is approaching to 5, x minus 5 is also approaching to 0, right? X minus 5 is approaching to 0, x minus 5 is less than 0. So, combining these two, one thing is very clear that 1 by x minus 5 is approaching to minus infinity because it's a negative value, right? So, the denominator is negatively very small. Since the denominator is negatively very small and its value is almost approaching to minus infinity. Since 1 by x minus 5 is approaching to minus infinity, what you say about e power 1 by x minus 5? And that e power 1 by x minus 5 is approaching to e power minus infinity. What is e power minus infinity? E power minus infinity is simply 1 by e power infinity. And we know e is a fixed constant, Euler's constant, approximately 2.7, and its power infinity is again infinity. So, 1 by infinity is 0. So, as extending to 5 minus, if you analyze, if you develop e power 1 by x minus 5 from x, this e power 1 by x minus 5 is almost 0. Since it is approaching to 0, so you just replace this e power 1 by x minus 5 with 0. So, finally, what you say about the limit? Therefore, limit x tends to 5 minus 2 e power 1 by x minus 5 minus 1 divided by 3 minus 4 into e power 1 by x minus 5 is equals to 2 into 0 minus 1 divided by 3 minus 4 into 0, because this particular thing is almost approaching to 0. And on simplification, this is 0 minus 1 and that is 3 minus 0, your answer is minus 1 by 3. So, the left hand limit for this particular function is minus 1 by 3. Whereas, if x is tending to 5 plus, if you are thinking about what right hand limit, then you need to develop, you need to analyze in another way. Okay, you just try it. You just try to find limit x tends to 5 plus of this particular function. Okay, so this is the first bit, and now I am going to calculate the second one, limit value for the second function as extending to 2 plus. Okay, right. Just have a look. Here x is tending to 2 plus. As x is tending to 2 plus, what we need to say? As x is tending to 2 plus, again the restrictions are what? X is nearer to 2 and x is greater than 2. Since x is greater than 2, as we learnt, what is step x? Since x value is nearer to 2 and greater than 2, step x is 2. Okay. And one more thing is, x is greater than 2, right? I need to calculate x by 3 also. Since x is greater than 2, what to say about x by 3? X by 3 is also greater than 2 by 3. 2 by 3 means what? Approximately 0.6 something. So, x by 3 value is approximately equals to 0.6 something, and when you calculate its step x by 3 is 0. Because x by 3 is nearer to 0.6, its step value is 0. So, its value is 0, step x by 3 is 0, step x value is 2 because x is tending to 2 and x is greater than 2. Finally, as x tending to 2 plus, if you wish to calculate this one, step x replace with 2 cube by 3 minus step x by 3 is 0 minus 0 cube, and this value is 8 by 3. So, as x tending to 2 plus, the limit of the function is 8 by 3. There ends the second bit. And now, I am going to handle this bit z. limit x tends to 0, sin step cos x by 1 plus step cos x. And before that, have a look. Here x is approaching to 2 plus, x value is greater than 2, so step x value is 2. And since x is greater than 2, x by 3 is nearer to 0.6, so its step value is 0, because you know the definition of step function, right? Finally, our answer is 8 by 3 for the f. Okay. Now, think about z. Limit x tends to 0. Sin of step cos x by 1 plus step cos x. Here x tends to 0 is asked. There is, see, the question is not mentioning about left and right limits. You just think about both left and right limits, okay? Left hand limit and right hand limit, okay? Yeah, here x is tending to 0 minus, here x is tending to 0 plus. What is this x actually? This x actually is a value in the domain of this cos x, because cos x involved, right? That in the sense x is an angle, x is a real angle. As x is tending to 0 minus, one thing is very clear, x values are less than 0, that means x belongs to fourth quadrant. As x tending to 0 plus, the values of x are more than 0, so here one thing is clear, that x is in first quadrant. You just think about cos x. Either x in fourth quadrant or x in first quadrant, in both the cases cos x is greater than 0. Positive, right? Since cos x is positive, its values are in between 0 and 1, which is positive in between 0 and 1, so step cos x is clearly 0. So, as x tending to 0, either for left hand limit or for right hand limit, if you observe, step cos x value is 0. So, no need to find out this limit value separately for left and right, directly replace step cos x with 0, because for both step cos x value is 0, sin 0 by 1 plus 0. As we know, sin 0 is 0, 0 by 1 is equals to 0, so the limit of this function as x tending to 0 is 0. So, this is the way to calculate left limit, right limit and limit of a function at a point. As I said, for some functions whose definition is different, in left and right sides of a, limit x tends to a, f of x not exist, because its left limit is not equals to right limit. But whereas there are some functions whose definition is same in both sides, then for those functions to find limit, no need to calculate left limit and right limit. It is enough to calculate the limit value directly just by calculating its functional value at the point. Next thing is algebra of limits. As you know, algebra of functions from functions concept, those rules and laws of algebra of functions helps us to develop algebra of limits. Let us look at slide which includes fundamental theorems on algebra of limits. One thing is very clear, if limit of f of x is L as extending to a and limit of g of x is m as extending to a, then for f of x plus g of x, the limit is L plus m. For f of x into g of x, the limit is L into m, and for f of x by g of x, the limit value is L by m. Likewise, easily we will use the limit over constant multiplication, over composition, over the power of the function and everything. Just observe the slide about the algebra of limits. As I said, if the definition of the function is same in left and right sides of a point A, then no need to calculate left and right limits. It is enough to calculate limit directly as its functional value. For suppose limit x tends to 2x square. See, for x tends to x square, if you calculate left limit and right limit, both are equal and that is equals to 4. Why they are equal and that is equals to 4? Because the definition of the function is same in left side of 2 as well right side of 2. So, for those type of functions, directly you just calculate the limit value as its functional value at the point 2, which is 2 square, and that is equals to 4. Now, for suppose think about the function x power x, limit x tends to 3x power x. As extending to 3x power x, the limit value is very clear, and which is 3 power 3, that is equals to 27. Because the function, the definition and the nature of the function is same in the left and right sides of that point 3. Okay? And now, limit x tends to 5, x square minus 4 by x minus 2. This particular function, the definition of this function is same in the right side of phi as well as left side of phi. So, its limit value is directly its functional value phi square minus 4 divided by phi minus 2. Phi square is 25 minus 4 is 21 divided by 3. That is it. And now think about this. Limit x tends to 2 x square minus 4 by x minus 2. Again, for suppose if you calculate its limit value as its functional value at the point directly, replacing x with 2, what will happen? If you replace x with 2, that is equals to 2 square minus 4 by 2 minus 2, that is equals to 0 by 0. See, look at this particular form 0 by 0, and this has no meaning in mathematics, and we call these type of forms as indeterminate forms. Indeterminate form in the sense there is no any specific sense or meaning related to it in mathematics. Okay? So, when you calculate limits directly, if you face these type of indeterminate forms, what are indeterminate forms? I mentioned here there are different indeterminate forms: 0 by 0, infinity by infinity, 0 power 0, 1 power infinity, infinity minus infinity. All these things are indeterminate. These forms has no meaning here. Okay? Okay. So, if you face these type of forms, you need to avoid those forms. Okay? So, do not get confused about that determinate form and indeterminate form. I think you all have a clear idea on those forms, because this particular concept is already cleared in our regular class. Okay? See, these are determinant forms here: infinity minus infinity, okay, 0 by infinity, infinity power infinity, infinity plus infinity, 0 by something by 0 which is infinity, something by infinity which is 0. So, these values are determinant, okay, because its value is infinity, its value is infinity, its value is 0, its value is infinity, its value is infinity, something by 0 is infinity, and something by infinity is 0 if that something is finite value. These are all determinant forms and these are all indeterminate forms. Since these forms have no sense here in mathematics, we need to avoid those indeterminate forms. Okay? So, now here when you look at this particular problem, limit x tends to 2 x square minus 4 by x minus 2, when you replace x with 2, your answer is 0 by 0, it is an indeterminate. To avoid this indeterminate form, we need to use our logic and certain mathematical techniques. You need to use different mathematical techniques to avoid these indeterminate forms, like factorization, rationalization, simplification, certain geometrical ideas, trigonometric ideas, and certain calculus ideas also. Already you learnt all these techniques to avoid indeterminate forms in our regular class, and so now I am going to discuss, I am going to generate different standard formulae and to solve different problems just by using calculus methods like L'Hospital rule as well as series expansion. Okay? I am going to use series expansions as well as L'Hospital rules to solve different problems in these video classes, because all other techniques, all other algebraic and geometrical tricks and techniques are already cleared for you in our regular classes, right? So, here these are the indeterminate forms, right? If you face this 0 by 0 or infinity by infinity, to avoid these forms, we need to use either factorization or we need to use either L'Hospital rule, or sometimes we may go with series expansions also. Either by using any one of these techniques, we will avoid these indeterminate forms. And to avoid this 0 power 0 and 1 power infinity, we need to apply logarithm to find out its finite value, its determinant value, by avoiding indeterminate. And for indeterminate form infinity minus infinity, to avoid it, we need to go with either simplification process or with series expansions to avoid indeterminate forms. Okay? And further, I will handle different problems using these techniques to avoid indeterminate forms. And here in particular, for this limit x tends to 2 x square minus 4 by x minus 2, since the value is 0 by 0 which is indeterminate, to avoid this, initially here I am going to use factorization. This is very clear for you. limit x tends to 2 x square minus 4 by x minus 2, you just rewrite it like this, limit x tends to 2 x minus 2 into x plus 2 divided by x minus 2. Here x minus 2 and x minus 2 gets cancelled. Why? Because they are not equals to 0. Why? Since x value is not 2, x value is nearer to 2. Okay? Since x value is not equals to 2, these two are not zeros, so we have a chance to cancel it out, and as extending to 2, x plus 2 is directly 2 plus 2 and the limit value is 4. Just have a look. If you substitute x as 2 in this function, its direct value is indeterminate, but by using factorization trick, the limit value is 4. So in the same way, if your answer is indeterminate for any problem, we need to avoid that indeterminate by using any one of the mathematical tricks, okay, mathematical techniques. And now I have another problem. Limit x tends to 1 plus x divided by 2 plus x to the power 1 minus root x divided by 1 minus x. What will happen? See, if you replace x with 1 directly, if you wish to calculate its limit, just directly calculate its functional value. 1 plus 1 is what? 2. X is 1, right? 2 plus 1 is what? 3. 2 by 3 to the power, replacing x with 1, 1 minus 1 by 1 minus 1, what it means? 0 by 0. Again 0 by 0 is an indeterminate. To avoid this indeterminate, again you just go with factorization. So how to factorize it? So for that, since it is indeterminate 0 by 0, so don't calculate the limit directly. First of all, you just try to avoid that indeterminate form. Limit x tends to 1 plus x by 2 plus x to the power 1 minus root x divided by, here this is 1 minus x, we have a chance to rewrite that 1 minus x as 1 minus root x into 1 plus root x. Now, you just cancel out this 1 minus root x and 1 plus root x. So, indeterminate form is avoided. And now you just replace x with 1. So, your answer for this is 2 by 3 to the power 1 by 2. Replacing x with 1. 1 plus 1 is 2. 2 plus 1 is 3. 1 plus root 1 is 2. So, 2 by 3 to the power 1 by 2. So, in this way, calculating limits for the functions directly, by avoiding indeterminate forms, we will do different problems. So, if the function definition is same in the left and right sides of a point, no need to calculate left and right limits, directly calculate limit value as its functional value directly. While calculating limit directly, if your answer is indeterminate form, to avoid that we have different mathematical techniques. And you all know all those mathematical techniques to avoid indeterminate forms. So, now in these classes I am going to use L'Hospital rule as well as series expansions to solve different problems. See, what is L'Hospital rule? L'Hospital rule is completely based on derivatives. I think you know about that L'Hospital rule also, because derivatives is also cleared in our regular class. See, in calculus, all those chapters are interlinked. Limits and derivatives are interlinked. To solve different problems of limits, we get the help of derivatives. As well, to generate certain standard derivatives, we use the concept of limits there. So, here we are going to use L'Hospital rule, and for that we need different derivative formulas. You just look at the slide of all your known derivative formulas here. Let us look L'Hospital rule, which we are going to use to generate different standard limits and to solve many problems, as a slide on your screen. See, if limit x tends to a f of x by g of x is indeterminate form either of 0 by 0 or infinity by infinity, then the limit value is equals to limit x tends to a derivative of the numerator divided by the derivative of denominator till to get a determinate form. We repeat the process. Just have a look here. L'Hospital rule. L'Hospital is a French mathematician. he develops this particular rule to find the limits by avoiding indeterminate forms 0 by 0 or infinity by infinity with the help of derivatives. Since you all know different formulas related to derivatives, here I am going to use this L-Hospital rule. First of all, directly substitute that a in the place of x. So if you directly substitute a in the place of x, what will happen? You will get your answer as f of a by g of a. And this particular f of a by g of a, either 0 by 0 or infinity by infinity, to avoid that indeterminate form, use L-Hospital rule. So this rule helps only to avoid these two indeterminate forms. How can we avoid? We avoid it by equating this limit for this. So limit x tends to a f of x by g of x is equals to limit x tends to a f dash of x by g dash of x. Now again replace x with a. Observe the value numerator by denominator. Again, if it is equals to 0 by 0 or infinity by infinity, continue the process, or if it is a determinate value, then stop the process there. So using this L-Hospital rule, now I am going to generate different standard limits here. So the first thing is limit x tends to a x power n minus a power n by x minus a. You all know the standard formula for this limit. What it is? N into a to the power n minus 1. We may solve it, we may find it either by using factorization, and now I am going to use by L-Hospital rule. Limit x tends to a x power n minus a power n by x minus a. Directly replace x with a power n minus a power n by a minus a, and that is equals to 0 by 0. This is an indeterminate form. So now I have a chance to utilize the L-Hospital rule. So according to my L-Hospital rule, limit x tends to a x power n minus a power n by x minus a is equals to limit x tends to a d by dx of x power n minus a power n. We need to calculate derivative for the numerator as well as derivative for the denominator. So d by dx of x minus a, and that is equals to limit x tends to a. So what is the derivative of x power n? So the derivative for x power n is n into x to the power n minus 1. Is it clear? You just recall the formula of derivatives, right? Minus, what is the d by dx of a power n? Since a is a constant, a power n is a constant, its derivative is 0, divided by derivative of x is 1 minus derivative of a is 0. So minus 0, 1 minus 0, all this is equals to limit x tends to a n into x power n minus 1. Directly replace x with a and your answer is n into a to the power n minus 1. So always no need to go with L-Hospital rule, always no need to observe as indeterminate form. Directly, if you face this type of situation, calculating limit for x power n minus a power n by x minus a as x is tending to a, your answer is n into a to the power n minus 1. So this is equals to n into a to the power n minus 1. Let us look at the second one. I mentioned here one example. Limit x tends to, right, we need to take it as 3, right? Okay. Limit x tends to 3 x power 7 minus 3 power 7 by x minus 3. Directly if you replace x with 3, 0 by 0 indeterminate form. So to avoid, use L-Hospital rule, or you may use factorization, or you may use this standard limit. What is this standard limit? So power n into this base a to the power n minus 1. So with that trick, what is its value? This is equals to 7 into 3 power 7 minus 1, that is equals to 7 into 3 power 6. There ends the problem. Actually, that's the benefit of learning standard limits, right? Now let us think about the next one. Limit x tends to a x power m minus a power m by x power n minus a power n. We need to calculate its limit value. Again, we have different chances to calculate it. First of all, directly if you replace x with a, its answer is 0 by 0 indeterminate. But we won't accept that indeterminate forms. To avoid, go with factorization, go with L-Hospital rule, or go with this standard limit. That's your choice, okay? But here I am moving with L-Hospital rule, okay? So what is this? This is equals to limit x tends to a derivative of numerator divided by the derivative of denominator. For x power m, what is the derivative? M into x to the power m minus 1 minus 0. For constant a power m, it's 0. And for x power n, what it is? N into x power n minus 1 minus 0. So, limit x tends to a, m into x power m minus 1 by n into x power n minus 1. And on simplification, this is equals to limit x tends to a, m by n into x to the power m minus n, usual law of exponents. X power m minus 1 by x power n minus 1 is simply nothing but x power m minus n. If you replace directly x with a, m by n into a power m minus n is your limit value. So, limit x tends to a, x power m minus a power n by x power n minus a power n value is always m by n into a to the power m minus n. So, this is another standard limit. And now, let us think about this particular problem. Okay? What is that? Limit x tends to 0, a power x to the power p by q minus a minus x to the power p by q divided by x. Again, if you replace x with 0, a plus 0 is a to the power p by q. A minus 0 is a to the power p by q. So, the difference is 0 by 0 is indeterminate. To avoid, use L'Hospital rule or use standard limit. But now I am going with L'Hospital rule only. So, this is equals to limit x tends to 0, derivative of this function. See, you know the derivative of x power or something to the power n. Derivative of something to the power n is n into something to the power n minus 1 into d by dx of that something. I think you all know it, right? N into something to the power n minus 1 into d by dx of something. Here that something is nothing but a plus x and that n is nothing but p by q. So, its derivative is p by q into a plus x to the power p by q minus 1 into derivative of this something. For a it is 0, for x it is 1, so take it as 1 minus again the same format, something to the power n which is p by q. So, minus p by q into a minus x to the power p by q minus 1 into derivative of a minus x. For a it is 0, for minus x it is minus 1 divided by the denominator x and its derivative is 1. Okay. How can we simplify? Minus into minus is plus, right? So, this is equals to directly apply x as 0. If you directly apply x as 0, this is equals to p by q into a plus 0 is a, right? A to the power p by q minus 1 minus and minus is plus p by q into a minus x. As x is tending to 0, replace x with 0, a minus 0 is 0, a to the power p by q minus 1. So, both the quantities are same, p by q, a to the power p by q minus 1. If you add these two, 2 p by q into a to the power p by q minus 1. And finally, for this particular problem, your answer is 2 p by q into a power p by q minus 1. This particular formula helps you in many situations to calculate the or to write the answers directly. Okay? In the same way, if you think about this particular problem, a is here nothing but 1, right? A plus x, 1 plus x, a minus x, 1 minus x, right? And here, see p by q and p by q, I am just taking it as m by n and m by n. So, simply replace a with 1 here, 1 power anything is what? 1. So, your answer for the problem is 2 m by n directly for this particular problem. And these are some simple examples which we can develop using this standard limit with the help of L'Hospital rule. You may answer many questions related to this from your material based on this standard limit. Okay? Likewise, using L'Hospital rule, I will generate different standard limits, and using those standard limits, I will solve many problems in these classes. So, that is for this video class 1 of limits. In this class, we learnt about the basic definition of limit, which is simply nothing but analyzing the nature of the function in the surroundings of a particular point. And while analyzing, we need to concentrate on left hand limit and right hand limit. So after discussing about left hand limit and right hand limit, the next idea is calculating the limit value directly if its definition is same in the left and right sides of the point. While calculating the limit directly, we need to replace x with a in the given function, and if that functional value is a determinant value, our limit value is that determinant value. Whereas if that answer is indeterminate, to avoid that indeterminate, we go with different mathematical techniques, and in particularly I am concentrating on L'Hospital rule, and in the further classes I am going to concentrate on series expansions. And that's for the class. You just revise all your known standard limits, all your known standard derivatives to continue with the next class easily. Thank you.